Okay, so welcome. This is Math 2531, Calculus 3. My name is Rob Dukes, and I'd like to go over some of the procedures in here. So, first thing I like to get to know each other. So I have 5 questions I like to ask that I've been doing for a while. Your name, your major, your hometown, the greatest challenge you've had, past or present, and your first job. So like I said, my name is Rob. I was a math major and an education minor in school from Charleston, South Carolina, where I worked for a while as a middle school teacher, and that didn't work out for me so well. So I switched to teaching community college and decided I liked that better. And so I decided I would go back to get a PhD to try to make that a career. And that was my greatest challenge, I'd say, was leaving Charleston, moving across country to Denver, where I worked on PhD for a few years, and that didn't work out either. So I moved down here to Albuquerque to start over. First job I had was working at Hardee's, which out here is called Carl's Jr. And so now we'll go around the room and everyone answer the questions and some of the procedures. Correspondence syllabus is on UNM Canvas page, and I will be using Canvas a lot in this. 2 days a week, I like to give a traditional lecture. On Thursday, we have what I call a problem-solving session. We'll work out homework or other problems I might assign, other activities. All class meetings are mandatory. So even if you're going to see the video lecture, you're still expected to come every day. If you miss more than 4 class sessions, you might get dropped from the class. I don't do that often, but it's an option. Homework is due Monday night, 11:59 p.m. I recommend starting each assignment on Tuesday, and I like to print out the homework and make copies because we have unlimited print queues and you don't, so I can let me count how many people want me to bring in and print out the homework each week. Write that down so that I remember. Let's see, what else do we have? Let's go through a few more procedures. Every day we have a short quiz, usually just about 5 minutes, right at the beginning of class. So you have to be here right at 5:30 when we start. There are no makeup quizzes for any reason, but we do have reviews at the end of each unit where I let people make up missing points. Test dates are fixed. If you know for sure you're going to have a conflict, let me know as soon as possible, because we don't do makeup tests unless you have some excuse, but if you know in advance, we can work out a special time. And we have what's called the Life Happens, which means 2 homeworks and 3 quizzes will be dropped at the end of the semester. Ebooks available under the module section of Canvas. A few more things. There's my contact information. I give a free quiz if you find the calculus table and get someone to sign a little paper that says, I found the calculus table. My office here is in SMLC 323, that's sort of the other end of the lake, of the duck pond. I'm usually there from like 2 to 5 or 2 to 4 when I'm not in the calculus table. But if you want to just drop in or just come see me, send me an email if there's a special time, and I try to be as open as possible. I want to try to respond to emails as quick as possible, so stay in touch. Now let's talk about what exactly happens in Calculus 3. So the theme of this class for me is don't reinvent the wheel. Everything we do in Calc 3 is really just an extension of what we did in Calc 1 and 2, mostly Calc 1. The history here, in the 15th and 16th centuries, we had the basic build-up for calculus. 17th century, we got calculus itself. And then once we get to the 19th century, we get into multiple dimensions, and that's where we're going to be spending. So I call this Calculus 1 with a steering wheel. You can see some of the basic problems. Here's tangent lines in 1 dimension, tangent line in 3 dimensions. Find a max, find area, find volume. And so our overview, this is the basic options. Chapter 12 will be geometry. Chapter 13 will be scalar to vector. Chapter 14 and 15 are vectors to scalars. And chapter 16, the final one, is vectors to other vectors. And that's all the basics here. Any questions about how things are going to go?